Let us recap the volume and surface area of a cuboid. The volume is length into breadth into height. The surface area is 2 times b plus l times h. And the total surface area is 2 times bh plus lh plus lb. A cube is a special type of a cuboid where all its dimensions are equal. So we can represent the length, breadth and height with A. So volume of a cube would be A times A times A. The lateral surface area would be 2 times A plus A times A, and the total surface area would be 2 times A square plus A square plus A square. Upon simplification, the volume becomes A cube. The lateral surface area becomes 4A square, and the total surface area becomes 6A square. Let us look at the lateral surface area. We see that there are 4 faces or 4 squares, hence 4A square. Let us look at the total surface area. There are 6 faces or 6 squares with side A, hence 6A square. Let us look at a problem. A solid cube of side 12 cm is cut into smaller cubes of equal volume. If the volume of smaller cube is 1 by 27 of the bigger cube, find out the side of the smaller cube. We are given a cube of side 12 cm. We are also given that the volume of smaller cube divided by volume of bigger cube is equal to 1 by 27. Let us represent the side of the smaller cube with the small letter A. And let us represent the side of the bigger cube with capital A. So, small a cube divided by capital A cube is given as 1 by 27. We could write 27 as 3 cube and 1 as 1 cube. Finding out the cube root on both sides, we have small a by capital A is equal to 1 by 3. Let us substitute the value for capital A as 12 cm and cross multiply. Let us simplify. We get small a as 4 cm. Let us look at another problem. A solid cube of side 10 cm is cut into 8 cubes of equal volume. Find the ratio of surface area of the bigger cube to smaller cube. We are given a cube of 10 cm. Now let us cut this into 8 cubes. Each cube would measure 5 cm. Now we have to find the surface area of smaller cube divided by surface area of bigger cube. Let us represent the side of smaller cube with small a and the side of bigger cube with capital A. So we have 6 small a square divided by 6 capital A square. Let us substitute the values for small a and capital A. Let us simplify. We get 1 by 4. So, the surface area of smaller cube divided by surface area of bigger cube is 1 by 4. Let us look at another problem. A solid cube of side 10 cm is painted red and cut into 8 cubes of equal volume. Find the ratio of painted surface area to non-painted surface area of the new cubes. So we are given a big cube which is painted red. So we can find the painted surface area as the total surface area of this cube, which is equal to 6 capital A square or 6 times 10 square. which is 600 centimeters square. Okay, now let us cut this into 8 cubes. Now each cube would have a side of 5 centimeters. Alright, we have divided this into 8 cubes. But how do we find out the non-painted area of this? Oh my, this is more difficult than I thought. Is there another way around this problem? We could actually find out the total surface area of the smaller cubes and subtract the painted surface area which we found from the bigger cube. So the total surface area of the smaller cubes would be the number of small cubes multiplied by total surface area of one small cube, or 8 times total surface area of one small cube, or 8 times 6 small a square. Let us substitute the value of small a as 5. So we get 8 times 6 times 5 times 5. How do we make this calculation easier? Let us club 6 and 5 together, and let us club 8 and 5 together. 8 times 5 gives us 40, and 6 times 5 gives us 30. So we get 1200. Now let us subtract the painted surface area from 1200. We get the non-painted surface area as 600 centimeters square. Now let us find the ratio. The painted surface area divided by non-painted surface area is equal to 600 centimeters square by 600 centimeters square, or 1. Wow, they actually turned out to be equal. Does that make sense to you? Let us look at this intuitively. If you look at one small cube, any one of the small cubes, then the number of painted faces is equal to the number of non-painted faces. Check this out for any one of the small cubes. Let us recap the volume, lateral surface area and total surface area for a cube. In the next lesson, we shall look at the surface area and volume of a cylinder.